on Home Factory. We spin a yarn about a rug.
Then we find out what makes a clock tick.
And take a seat on a famous chair.
But first, we take a quack at a bubble bath. Oh, yeah.
The ultimate bath time companion.
I am so listening.
Meet Ducky. He's hatched here at Celebriduck's 21,000 square foot facility in the Bronx, New York, a rough and tumble neighborhood that's just filled with too cool for school New Yorkers and rubber ducks.
Okay, so and who are these two here?
My name is Alan Backelman.
I'm Mike Backelman.
I'm his father.
I'm his son.
Family business, huh? I'm sensing some tension.
Welcome to my world.
Oh,
Sorry.
you're walking home tonight?
Well, one thing they agree on, they love rubber ducks.
What's not to love? They keep things in perspective. I mean, no matter how bad things can get, just look at them. It's hard to be worried about stuff when you're looking at rubber ducks, right?
Jody Davis, a director of marketing for Celebriducks, certainly thinks so.
Celebriducks takes us back to our childhood. It's purity, it's innocence. Heavens, it's a bubble bath. I mean, what gets better than that? So, and they're yellow, they're happy.
And apparently there's a lot of happiness to go around.
Over the years, we probably have made several millions of rubber ducks.
So we'd better get quacking.
Really? We're going there?
Uh-huh.
Okay. 400 grams of liquid yellow plastic is poured into duck-shaped molds, which are then placed in a rotational oven to harden.
The rotational oven is a bit complicated for you and me, but Mike has come up with a handy comparison.
Think of an Oreo cookie. People do this when they twist their Oreo cookie open. That's what the two plates inside are doing. They're turning like that.
This means the inside surface of the mold is coated, leaving the inside of the duck hollow.
And the ducks are cooked at a temperature of 150 degrees Celsius for 15 minutes.
Quack, quack.
I'm thinking that quack means the ducks are done. When the ducks are cooked, they're pulled from the oven and plunged into a cold bath to cool them down in preparation for the extraction process.
This is a little delicate, but let's just say the ducks are pulled from their molds bottom first.
Looks like some of them get stuck.
Sometimes.
Looks a little undignified.
Yeah, it's the only way to do it, unless you want to sculpt every one of them.
Extracted ducks are brought here for buffing and trimming to get rid of any excess plastic.
Then the smooth, polished ducks are ready for painting, which goes a little something like this. Orange beak. Work it, ducky! Work it! White eyes. Black pupils. White highlight. Polish. And done.
This is Lizzie.
And that is her duck face.
Lizzie's going to tell us about duck painting.
We have to keep the duck in the row.
Lizzie and her team can paint 2,500 ducks in just half a day.
Wow. Painted, polished ducks are brought to Myrtelina in quality control.
She's inserting 50-gram weights into the duck's undercarriage,
Ooh, saucy.
which will make them float, which is important because...
Well, because you want them in the bathtub, they gotta float. All of the Celebriducks are weighted on the bottom. You throw him in on his head, he will go upright. Now that's a rubber duck.
Which is why Myrtelina conducts this highly scientific float test to make sure they don't sink.
Dead duck. If they don't float. Dead duck.
Dead duck. The surviving ducks are sent to be packaged.
First, they're individually wrapped. Then they're boxed and sealed, ready for distribution to, well, mostly Jody.
I must have at least maybe 300 rubber ducks, which isn't a lot at all.
No. Not a lot at all.
This is the duck that I designed. This is my quilting rubber ducky. And then this is one of my Dixie duckies.
Well, okay. Is it weird that I now want a whole bunch?
Celebra ducks are shipped everywhere because we want to spread the love as far as we can.
People should buy rubber ducks because I have kids to put through school.
Well, then it's good news that in homes across the country, there's basically a pandemic of rubber ducks tumbling into bathtubs and emerging phoenix-like from the bubbly depths.
Turns out rubber ducks are all they're quacked up to be.
I knew you wouldn't be able to resist. Behold, the Braided rug. A uniquely American product, this rug ties an entire room together.
It certainly does. From Colonial Mill's 70,000 square foot facility in Pawtucket, Rhode Island, these rugs are made from 100% USA sourced yarn.
This is Colonial Mill's founder, Don Scarlatta. And these are his kids, Greg, the VP of Sales, and Meredith, the Creative Director.
Hey, Greg, Meredith, what's it like to have your dad as a boss, huh?
Want me to leave?
Yes, Dad.
I'll leave.
Are you too scared of your dad?
Not anymore.
No, not anymore.
It's okay. He's gone. It's all right.
Well, we grew up not really wanting to be in the business, to be honest with you. Going to work for your father was probably the last thing I wanted to do.
Especially knowing how meticulous our father is.
Yes.
I'm known as a neatnik. I mean, Mr. Organization, right from the top to the bottom. The way I operate, the way the factory is kept, I like everything in its place.
Well, it's obviously a system that works because Colonial Mills manufacture around 200,000 rugs each year. And each of those rugs starts its life right here, where raw yarn is held on giant spools.
That yarn is taken to the winding room, where it's unwound onto bobbins to create unique color blends.
Yeah, this means combining different colored threads to make one multi-hued thread that will be used in the final braid. Gilberto is in charge of this department. He looks pensive.
Okay, and how many colors have you got cooking, Gilberto?
Too many. A lot.
Once the color blends have been created on the bobbins, those blends are cut and tied to a plastic center in preparation for braiding.
3 bobbins are used per machine, and the yarn is woven automatically to create the braid.
The bobbins are braided together around polyester filler. That filler creates a stable core to work around, so the final rug will be easier to sew.
The end result is a flat braid, which is wound into a holding barrel. These guys are braiding about 1.2 million kilometers each year.
So essentially, we can braid enough braid for a 5x8 rug in under 20 minutes.
Those braids are brought here to the machinists.
Hey!
Hi there. You know, they're given exactly 29 minutes to sew a rug.
No need the 29. Need maybe 26. No, the same people, maybe 29, a little bit more.
Sounds like someone's angling for a raise.
I'm thinking. Fatima sews the rug from the center outwards, adding layers of braids as she sews.
To help spin the rug while they sew, the machinists use this air table.
Yeah, it's cool. It's basically like a giant air hockey table. Wow.
Holes in the surface create a cushion of air, which reduce friction to help the rug move smoothly and quickly across it.
Which makes sewing faster and playtime more fun. The finished rugs are wheeled through to packaging, where they're wrapped, labeled, and sent to homes everywhere, including Mickey's house? Really?
Our rugs are actually in Mickey Mouse's house in Disney World.
Sure, Mickey's house. But also just regular houses for regular humans to enjoy, right?
Yeah, I mean, I don't want to be a downer or anything, but don't you guys think these rugs are a bit too nice to put on the floor?
Yeah, I know what you mean. Do those people have their feet on the rug? Don't you know this thing was handmade? How about a little consideration, huh?
Okay, that's it. Everyone out. Nice. and hover.
How'd you do that? Chelsea clocks. They're like regular clocks, except they're handmade. They don't take batteries and very fancy.
And even though the world's finest minds have grappled for over 400 years with the mechanics of time,
it took the home factory team less than 7 minutes to master the mechanics of clocks.
So without further ado, set your watches.
Okay, this is Chelsea Clock's 24,000 square foot manufacturing facility in Chelsea, Massachusetts. And we are go.
Meet J.K. Nicholas, CEO of Chelsea Clock.
And go figure, J.K. is a pretty time-focused guy.
1, 2, 3, 4, 5.
But being surrounded by clocks all day does have certain setbacks.
Chelsea Clock was founded just around 1897. I think it was in a garage for a few years before that, but that's when it was incorporated. We got a bell in there, right? Should we do it over? How many others are going to go off in the next 3 minutes? Because once we're through this, it's not going to go another half hour. Hold on, it's just, there we go. I knew it was coming, so why?
Okay, so with time being at a bit of a premium, I'm thinking we focus on 4 main things: the brass case, the gears, the dial, and the assembly.
Agreed. Clockmaking begins here with Bob.
My name's Bob Geek.
Bob is making the ship's bell clock, so called because they were designed for use by sailors.
Rings every half hour because when the sailors are on the ship, they know when they were going off duty.
So first, the case. This computerized machine spins a pre-made brass cylinder, smoothing and sanding it to get it down to an 18-centimeter diameter at a depth of 10 centimeters.
And then it's drilled with holes to make it easier to hang in your home.
And voila! The brass case is complete.
The case is then sent here for cleaning.
We're gonna clean your clock.
How was that?
Ah, perfect, Bob. Yep, his name is Bob, too, which is confusing for us, but not for Bob.
Bob, and Bob.
Bob buffs the brass using this wheel, then soaks it in an ultrasonic bath.
That is a tank of liquid flooded with high-frequency sound waves which create a scrubbing brush action within the fluid.
So it thoroughly cleans the brass and removes any imperfections.
And meanwhile, back to Bob. The clock's smaller components are created on these machines overseen by Bob. Would be the first Bob.
Automatic screw machines. They were built maybe 80 years ago, and they still went pretty good for their age. I hope I went that good at 80.
Each clock is made up of 365 parts.
You know, they're made in many ways the way that they have been for the company's history. Machines that, date back to World War II sometimes. That's pretty amazing, too.
Yeah, but with our own clock ticking away, we thought we'd home in on the gears.
The more gears you have, the longer the clock can go without being wound. So Bob is making 18 gears for the ship's bell using this hobbing machine.
Chelsea Clock prefers to cut gears, which allows for better accuracy in the finished clock.
Keep the time. Perfect time.
So with the case made and the gears cut, it's time to put on a good face. That's done by Dennis, not Bob.
I like a pretty face.
I'm a sucker for a pretty face.
First, he smooths the face using this potter's wheel, then applies a special silvering compound. Perfect.
Nothing is perfect, as we all know, but as close to perfect as we can get.
Sorry, almost perfect.
The clock is now ready to be assembled, so the dial, together with gears, and the remaining 363 parts that we didn't have time to make, are sent to be balanced and calibrated by Jeannie.
Action.
Jeannie's the master clockmaker and has worked here for 52 years.
I think by now I have the hang of it.
It's Jeannie's job to put the entire clock together, which takes about an hour per clock?
About an hour.
Really, Jeannie?
Half hour.
Okay, but the million-dollar question here is, which clock does Jeannie have at home?
The most expensive one.
Yeah, I bet that's a nice clock.
Gorgeous. Of course, it runs well because I made it.
Balanced, calibrated clocks head back downstairs to Humberto, who fixes them into their shiny brass casings and adds a gong.
Then, Umberto tests the accuracy by moving the hands in half-hour increments and listening to the chimes.
Further testing occurs for the next 7 days to make sure that each clock is absolutely perfect before it leaves the factory.
They have to be perfect. These clocks have been bought by rock royalty.
Elvis Presley, known to buy some clocks. The Grateful Dead actually purchased a bunch of clocks from us, and I'm not sure for what purpose that was.
And just royalty.
President Obama has purchased our clocks. His wife, Michelle, selected our product to bring to Europe on his first trip overseas.
That's a world-class client list. So what's it like working on a world-class clock?
It's an art, it's a craft. And you complete the clock, you know you did something great, especially when it works good. It usually does.
Okay, we're out of time, guys. Let's pack this clock up and get it out the door. These things need to be seen.
Yeah, these things also need to be wound. Hey, careful with that clock, lady. This one's handmade by Jeannie.
That's right. And there it goes, back on the mantelpiece. Phew. Ladies and gentlemen, please take a seat, for I have a remarkable story to tell you. A story starring...
The Humble Chair.
Humble? This is a legendary Emeco Navy chair, a virtually indestructible seat.
And to prove it, we're headed to Emeco's 250,000 square foot facility in Hanover, Pennsylvania.
And here to tell us all about the famous Navy chair is President and CEO of Emeco, Greg Buckbinder.
I used to surf every day. I'd surf before school, I'd surf after school. Sometimes I wouldn't go to school. You know, it's interesting. I don't know when it occurred. People, when they close their eyes and they think of a chair, they think of the Navy chair. The rumor was that the seat bottom was shaped after Betty Grable's bottom.
Hubba hubba.
The chair was designed for use on U.S. Navy ships, and it was built to last.
They had these big, burly sailors, and out at months at a time at sea would completely destroy any furniture. So they need something super strong.
These chairs begin as sheets of 80% recycled aluminum. Emeco goes through 300 sheets of aluminum in a month.
The metal is sheared into sections by this scary-looking machine with enormous teeth.
The sheets are then pressed in this seat mold, complete with Miss Grable's famous bottom.
The back legs and frame of the chair are formed by bending metal tubes into a U shape.
And the front legs are made by forming metal into squared-off tubes.
The next step is putting the whole thing together.
Emeco uses no hardware in their chairs, which means... Chair, I am your welder.
Just kidding. It's only Ralph, the lead man for the welding department.
Welding fuses metal together by melting the surfaces of the separate pieces and a metal rod, which acts like the glue. Each Navy chair has over ½ meter of weld.
Today, Ralph is welding the front legs to the seat.
Ralph, tell us why the Emeco chair is so sturdy.
Well, it's better made than anybody else.
Next, the back frame of the chair is attached to the seat by the same process.
You know, I could watch him do this all day.
Yeah, well, that's too bad, because it's time for the welds to be ground down into a smooth finish to make the chair look and feel seamless.
You can always tell the quality of a chair by the connections. There are no connections in this chair, and that's why the quality is so good.
And now that the chair is formed, it's time to harden that aluminum into place.
Which calls for a snazzy outfit.
Yeah, it's not just snazzy, it's also heat resistant, which is important because those chairs are going into a 530 degrees Celsius salt bath.
This is Wayne, the man in the hot seat at Emeco.
Hot seat, hot feet when you're standing there.
The salt bath practically melts the aluminum and realigns the molecules, making the chair into one solid piece.
The salt bath has to be covered because if any water gets in, it could cause an explosion.
So for fire start, run.
Yeah, noted. The chair is then plunged into cold water, which hardens the molten aluminum.
But the chair is still a little soft, so it can be leveled if it's not quite sitting straight.
Once the chairs are checked, they go into a 175-degree oven for 8 hours, which does the final hardening.
It makes it as hard as a mountain bike frame. So it becomes a super hard, durable chair.
After cooking, the chair heads to the Sanoflex department, where it's Francisco's job to
make it more sexy.
Each chair is carefully brush finished by hand. Is it hard work, Francisco?
A little, not too much.
And after all that hard work, it's time for a nice hot bath.
What, for Francisco?
No, for the chairs.
Oh.
This electrically charged bath causes a chemical reaction on the surface of the chair, creating a super hard finish. The process is called anodizing.
Well, I guess it's relaxing for the chair. After their spa treatment, the chairs head to a final inspection, and then glides are attached to all the legs.
Here's a chair that's never been in style and will never go out of style.
The chairs are wrapped and boxed up to be shipped to homes across the world,
where they can be used and enjoyed for years.
Looks comfy.
I call not doing the dishes.
Hey, not fair.
Plucked from the trash, everyday objects are destroyed, then transformed by technology, reborn into modern marvels. Aluminum ladders melt down into parts for oil tankers. Waxed cardboard boxes shred into fire logs. And skateboards roll into electric guitars. These are the things that are made by destruction. There's one leaning in every tool shed and loaded on every truck. The aluminum ladder is lightweight, strong, and rust-resistant. But eventually, these sturdy helpmates get grounded. Thanks to innovative technology and cost-effective techniques, broken down ladders are stepping up to a new job. Every year, Ram Iron and Metal takes 20,000 tons of scrap aluminum onto their 12,000 square meter facility and turns it into a new product that really delivers. Aluminum ladders are recast as parts for an oil tanker. But to build them up, you've got to break them down first. A salvage worker tosses the ladders into a bin. After heading for the warehouse, he offloads the bin into an alligator shearer. Wielding 34,000 kilopascals, the alligator's powerful jaws chew up the ladders into shippable sizes. Then, a worker loads them out into a waiting truck. It's a short ride to the smelter, where the chunks of ladder will be cooked back into raw material. A forklift dumps the scrap into a furnace. The aluminum liquefies at 732 degrees Celsius, then flows into a 6-meter deep casting pit. Once it's cooled, a crane lifts out a 113 metric ton aluminum ingot. The 60-centimeter thick ingot rolls back and forth in the reversing mill. 2,200 metric tons of pressure flatten the ingot to just over 2 centimeters, stretching the slab into a 91-meter long aluminum sheet. The aluminum is then shipped to manufacturers that will make many of the fittings for the tanker. To create the oil tanker, aluminum sheets are bent, rolled, and welded into the tank. The tank is harnessed to a truck bed, and vent hoses, gauges, and other systems are installed. Almac Tank International makes liquid transportation tanks in all sizes, from the 1,900 liter to the massive 34,000 liter capacity. To create the tank itself, Almac uses 100% virgin aluminum, free of recycled filler. The first step in creating an oil tanker is to join the aluminum sheets together. An overhead crane feeds 3 rectangular sheets into a seam welder. As the sheet travels through the seam welder, 2 computer-guided electrodes melt the edges of each sheet to produce the seam which joins them together. An operator marks the newly formed sheet with lines to indicate where it needs to be curved. A crane carries the sheet over to the rolling machine, where it will be bent to spec. The tech calibrates the roller to the exact angle of the curve. How much to bend depends on the final size of the tank. The roller makes 2 large bends in the sheet, defining the sides and the bottom of the tank. Workers guide the tank in progress to a spot on the floor, where they'll continue its assembly. The operators use hammers and torches to tack weld the ends of the tank in place. Interior supports, called baffles, are installed inside the tank to give it added strength. Workers install 2 triangular baffles that will form a spill basin if there's any overflow while the tank is being filled from the top. After taping protective panels to the surface to protect the aluminum from scratches, workers park the tank between 2 positioner machines. The positioner acts like a giant rotisserie, providing easy access for final seam welding. Sparking a MIG welder, the workers melt the aluminum shell at 3,500 degrees Celsius, carving a molten channel into the aluminum along the seam line. They fill it with metal filler to smooth and seal the seam. This is painstaking work, and it must be done right. One leaky weld could mean a disastrous safety hazard. Once the welding is completed, the tank is tested to see how it holds up under pressure. An inspector drops a water hose into the hatch and fills the tank to its 34,000 liter capacity. He seals the tank, then pumps in 34 kilopascals of air pressure in an attempt to breach the welded seams. If the seams don't hold, the tank could burst and it will need to be re-welded. The tank passes the pressure test. The water is drained and the tank is ready for the next phase of construction. Installers trick out the tank with pumps, plumbing, and gauges, then secure it to the truck bed. Metal workers chop, melt, and press discarded ladders into 90-meter sheets of pristine aluminum, which they shape and weld into a 34,000-liter tank. Eastway Tank Pump and Meter Limited turns a hollow aluminum tank into a fully functioning tanker truck. The tank has been transported to Eastway, where it's now positioned above a truck bed in the assembly bay. An overhead crane lowers the tank onto the truck's frame. An installer uses a pneumatic wrench to lock it in place. Then, technicians install the tanker's pumps, gauges, and other systems that will help it safely transport and deliver gas or diesel fuel. An inspector tests the entire pump and monitoring system to make sure every component is functioning perfectly. A worker applies a few finishing touches, and this rig is ready for the long haul. Aluminum ladders on their last legs have been rescued, recycled, and reformed into parts for oil tankers. And that's a step in the right direction. Waxed cardboard boxes are a popular way to get fruit and vegetables to market. The wax keeps the container water resistant and preserves the produce. Unfortunately, it also preserves the boxes. 1.5 million waxed cardboard boxes are produced every day in the US. All those boxes eventually end up in landfill. That's a mountain of boxes, 150 times the height of Everest. Thanks to an innovative manufacturing process, waxed cardboard boxes are being transformed into a hot new product. At their 6,500 square meter plant in Gridley, California, Clean Flame rescues 10 million cardboard boxes from the landfill, saving 200,000 trees every year. They can also save you some money on your heating bill. Waxed cardboard boxes reform into fire logs. To pull off this transformation, workers need to shred, dry, and extrude the boxes. The first step in destruction is sorting. A forklift ferries bales of flattened boxes to the sorting area. Produce boxes are made up of a corrugated sheet of paper sandwiched between 2 sheets of cardboard. The cardboard is coated with food-grade wax that helps the finished fire log burn slowly like a candle. Workers pick through the boxes, keeping the ones coated with wax and recycling the others. They also blend the wetter boxes with dry boxes to ensure the production line runs smoothly. The waxed boxes travel up the belt and drop onto a 4-shaft shredder. 4 sets of cutters repeatedly grab and shred the boxes, cutting them down into 5 centimeter by 5 centimeter cardboard chips. Once they're small enough, the chips fall through a grate onto a conveyor belt. Workers inspect the shred, pulling out bits of plastic and any non-waxed cardboard. The next step in the destruction process is heating. The 5 centimeter chips ride along a conveyor and land in a hopper, which feeds a dryer the size of 2 school buses. Inside the massive rotating drum, the cardboard is tumble-dried and heated. Wasted cardboard boxes have been reduced to 5 centimeter chips. Now they're ready to work under pressure. The chips will be packed into an extruder and reformed into clean-burning fire logs. The recyclers at Clean Flame sort, shred, and dry waxed, corrugated cardboard boxes, chopping them into 5 centimeter chips. Time for their transformation. The first step in the creation process is forming. The cardboard chips drop into an extruder. A spinning auger squeezes the shredded pieces together. The wax helps bind the compressed chips into a single log. After about a minute, a rectangular log emerges from the extruder and into the blade of a guillotine. The sharp edge slices the log into 60-centimeter chunks. An inspector weighs the individual logs. A 2-kilogram log will burn for about 3 hours. If the log is underweight, it goes back into the extruder to bulk up and get reprocessed. Once a log passes inspection, it heads down the line for packaging. Tightly wrapped in a paper sheath that's chemical-free and made for quick lighting. A shipper packs them into boxes and stacks them onto skids. Clean Flame produces up to 10,000 logs per shift. Visionary thinking and smart technology sparked a good idea. Cardboard boxes that might have ended up in landfill have become slow-burning logs. Step aboard a plank of wood with a set of wheels, and you're rolling with over 13.5 million sidewalk surfers. Most skaters can pull off these gnarly stunts without broken bones, but there are plenty of broken boards. Because of their unique construction, the wood can't be recycled. But now there's a way to turn sick tricks into cool licks. The craftsmen at Prisma in San Francisco have found a way to shred a skateboard in a sensational new way. Skateboards are transposed into one-of-a-kind electric guitars. Inside their home studio, craftsmen slice, strip, and layer skateboard decks into handmade instruments that are making a lot of noise in the music community. Every custom axe is made from 10 hard rock maple decks fused together to make a unique guitar body. The first step is stripping down the boards. The craftsman chooses decks that are different in color and grain, so when they're stacked together, they create a distinctive layered look. The guitar maker unscrews the wheels and suspension, or trucks, from the board. The hardware is set aside for reuse. Using a razor, he pries the grip tape from the top of the deck. Then he peels the tape away from the wooden surface. Decks come in all colors, so the 10 boards that build a single body create a cool palette on the guitar's surface. Step 2 is sanding. The craftsman uses an angle grinder to smooth away flecks of tape and surface flaws. He runs the deck under a bandsaw to slice off the nose and tail, cutting them down to uniform 45-centimeter by 19-centimeter rectangles. These X skateboards are ready for a rebuild. The boards will be glued, stacked, and carved until 10 discarded skateboard decks can go to 11. Prisma guitar makers take broken down skateboards, pull off the grip tape, strip down the hardware, and cut them up into boards. The multicolored maple is ready for recreation. The guitar maker picks 4 boards to layer into the guitar body. He applies a generous coat of glue on each board. Then, he spreads the surface for maximum coverage. The craftsman piles the tacky boards into a stack, then transfers them to a press. he cranks the press down, fusing the boards together into a single laminate. After 8 hours, the glue is dry. The craftsman pulls the laminate stack from the press. He feeds it through a planer that shaves away any bumps and blemishes, so the laminate is perfectly smooth and symmetrical. A joiner squares off and cuts down the sides, so they'll make a precise join with the other piece. The craftsman spreads glue along the sides of 2 laminate board stacks. He presses them together, then clamps them tight. After about a day, the guitar maker loosens the clamps. The glue has bonded the 2 stacks into a single solid block. He sands the surface to remove excess dried glue. The guitar body is ready to take shape. The craftsman traces a classic electric guitar template on the laminate surface. Then, he uses a bandsaw to cut along the trace lines. He follows up with a router to refine the lines and round off the multicolored edges. A plunge router digs into the body, hollowing out the cavities that will house the electronics, and a notch to fit the neck. A drill press cuts holes to anchor the guitar's bridge. The guitar maker uses a file to sculpt the cutaways and contours for added playability and style. He gives the instrument a final sanding to bring out the grain before the maple body is sealed. Finally, a coat of clear lacquer gives the instrument a protective finish and a high shine that enhances the one-of-a-kind color scheme. Time to make this guitar an electric guitar. Guitar pickups are magnets, wrapped with hair-thin copper coil. When the metal strings vibrate, they disturb the magnetic field and turn it into an electric current that's the same pitch as the vibrating string. This electronic signal travels to an amplifier, which converts it back into sound. The guitar maker solders the wiring to the pickups and connects them to the input jack and tone and volume controls. He screws the neck into place and winds the strings onto the tuning pegs. A guitar is born. All that's left to do is plug and play. When skateboards hit the street too hard, they can be turned into a finely tuned instrument. Sounds like an awesome idea.
On Home Factory, we run up the flag.
Then we get ourselves in a sticky situation.
And we find ourselves puzzled.
But first, we spin a yarn about yarn. You want to know what's cool?
All right.
Knitting is cool, and no one knows it better than Spin Right Yarn. This is the capital of cool. Spin Right Yarn's 210,000 square foot facility in Listowel, Ontario. And this is John Verway, operations manager at Spin Right. He's here to tell us what is hip.
It's hip to knit.
And he also knows what's cool.
and it's cool to crochet.
Why is that then, John?
And I'm a big Star Trek fan.
Oh, no.
I've actually seen on Star Trek where they have people knitting, so even in the 24th century, it's gonna happen.
Okay, but here in the 21st century, let's talk about how knitting has become cool again.
Knitting has always been cool. It's just for a lot of people who've been back in the closet a little bit.
Well, not anymore. Spinrite boasts the most extensive product line in the yarn industry.
And that starts here with the arrival of 360 kilogram bales of 100% raw acrylic fibers.
Those fibers are fed into a machine for gilling, which straightens them out and blends them all together to make a uniform color. Gilling is overseen by Tom.
Hi, I'm Tom. I've been here since '91.
So we're guessing he's a bit of a master of the gilling machine.
Hell no. I just do my job. Kind of.
The gilling machine pulls the raw fibers through a series of combs which straighten the strands.
The strands are then outputted into these spinning bins, ready for phase 2, roving.
Roving just prepares the wool for spinning, strengthening it, and cleaning it of any debris.
Okay, so let's start roving with the purple yarn. It's drawn from the drums over a sequence of parallel rollers.
These rub the fibers, adding a twist and making them stronger.
This is Arlene. Arlene enjoys knitting a lot.
Arlene's been knitting for quite some time.
I was knitting when knitting was cool.
Psst, Arlene, it's cool again, remember?
Arlene is responsible for replacing the full roving reels with fresh ones, which is happening, well, pretty much right now.
Okay, I gotta go. I gotta go get that.
Arlene grabs the full yarn reels and loads them into a hopper for transportation to spinning.
Where they meet Susanna.
Yeah, she's quite the spinning fan. At Spinrite, they produce 72 million balls of yarn every year.
That's a lot of spinning.
Well, let's get to it then. Spinning makes the yarn thinner or thicker, depending on what we want to use it for.
Today, we're spinning blue yarn. Spools are fixed above the spinner and then unwind through the machine. Once the yarn has been thinned, the threads can be twisted together and re-spooled to the thickness we want. This one spins at around 4,000 RPM, spooling about 550 meters each minute.
Next up, steaming, which happens in these steam tunnels at a temperature of 95 degrees Celsius.
What the steaming does is it gives the yarn then the ability to fully relax. Very similar to taking a sweater and putting it in low heat on a dryer. It tends to just open it up and give it that little bit of fluffiness.
The second tunnel dries the yarn and cools it back down to room temperature. This is Paula, who works with the baller. But what should we call her?
And okay, I gotta do that over. My name is Paula, I work in balling. Oh my God, one more, okay, let's get this one better. My name is Paula, I work in balling, and I like it steamy.
The ballers are a number of spindles around which the yarn is wrapped. Today, black yarn.
These guys can make up to 50 balls a minute. That's 3,000 per hour, or 72,000 each day. Once full, the yarn ball is ready to be sent to packaging, which happens like this.
Go deep!
Sadly not. This less fun conveyor ferries the yarn balls to a rotating clamp,
which wraps them in paper and sends them off to be bagged. Those bags are transferred to packing cartons by factory workers. 12 packets of yarn in every carton.
Nice. Kind of wondering, with all this yarn around, how many of these folks actually knit?
We know Arlene does, right?
What about Tom?
My wife would tell me I'm doing it wrong.
Guess not. Paula?
I'm learning.
I myself, I can knit, but you wouldn't want to see the end project.
Okay, so between all the knitting and the fun wigs and, well, this, I'm guessing these guys get through a lot of yarn.
We'll produce in any one day about 20,000 miles of yarn. That means that in 10 days, we could produce enough yarn to stretch to the moon.
Okay, that's useful, I guess, but I'm assuming that means there's also enough to stretch to pretty much every home in Canada.
Yeah, I guess so. But who's using all this yarn? Is staying home and knitting the new going out and partying?
Well, sure it is. I mean, I've been saying it for years. Friday night is all about the yarn, baby. Quick.
Okay.
What do you think about when you hear the word Canada?
Syrup-covered beavers playing hockey, eh?
What about the proud Canadian maple leaf?
Oh, yeah, that too. And to find out what goes into making a patriotic Canadian flag, we're headed to Flags Unlimited 65,000 square foot facility in Barrie, Ontario.
That's right. And this is Brian Dewsome, the team leader of finishing. And he's going to tell us all about how Flags Unlimited makes the best flags available.
Our flags are superior because of the richness of the color, the finishing detail, and the strength of the product itself.
Now, the first step for any flag is finalizing the design.
But since the Canadian flag already has a pretty fantastic design, it's kind of a slow day in graphics.
Okay. Let's fast forward to the printing stage, shall we?
This is another Brian. He's going to tell us what's going on in printing.
Well, basically, we're printing a Canada flag.
Oh, thank you, Brian. Flags Unlimited uses Duraknit 3 for their outdoor flags. The fabric resists fraying, so it's ideal for displaying outside.
We print on the best polyester fabric that's available in the marketplace.
Flags Unlimited uses water-based ink. The printer uses 2 rails, each putting down half the color.
What it does is it minimizes the amount of bleeding of the dye on the fabric and keep as crisp an image as can be.
It also saturates the fabric so the image can be seen from both sides.
It kind of looks a little dark to me.
Once it gets into the final process, which is setting the color in, it'll make that red pop. It'll be a nice Canada red.
And to set that color, the printed fabric goes through a giant set of rollers that pull it past a pair of heaters set to 205 degrees Celsius, which bonds the ink to the fabric.
Steamy.
Next, the printed and bonded fabric heads to the washing department. This is David, and he's in charge over here.
We're washing out the extra dye that's strapped into the webbing.
That way it won't bleed or transfer onto the crisp white background.
Now, large orders of flags are cut by machine, but specialty orders are cut by hand by Glacelyn and her team in the cutting department. Glacelyn and the cutting team follow tiny crop marks to cut each flag.
The cutters also remove a graphic code that was printed at the same time as the flag, so they can check the dye job, because all of the colors should be perfect.
Supposed to. It should be.
Glacelyn uses a device called a spectrometer. Ooh. It measures the printed color as light is passed through it to make sure the color is exactly as specified and hasn't faded or changed since it was printed.
Glacelyn, how many flags do you check in a day?
Oh, I can count lots.
The flags that pass are sent to the sewing department, where a canvas header is sewn on and then the edges are hemmed.
This is Lita in sewing, and she is a vital part of this entire operation and a proud Canadian.
Without me, it's not going to be Canadian flags.
Yeah, sing it, sister.
Oh, Canada, da 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 da. I don't know that one.
Ooh, that's okay, Lita.
Next, grommets are punched into the canvas header. Flags Unlimited uses spurred grommets, which means the bottom has spikes.
Spurs bite into the fabric and hold themselves tight in that header to withstand all of the air pressure and the wind and the rain and the snow and everything else.
Finished flags are folded and put into plastic sleeves with an information card and label. Flags Unlimited produces 1 million Canadian flags per year. That many flags would cover Prince Edward Island 10 times.
Wow. Then, the individually wrapped flags are boxed and shipped to retailers where true North patriots can buy them for their very own homes.
Every Canadian household should have one of these Canadian flags.
But it's not just Canadian flags that keep Flags Unlimited busy.
You can put just about anything on a flag.
Are you thinking what I'm thinking?
Back to the graphics department.
And now to the printers.
Heat setting.
Washing.
Cutting.
Color testing.
Sewing.
Grommeting.
And then...
Ta-da!
Home
Factory.
Our show and paycheck signer.
Just brings a tear to your eye, doesn't it?
Dippity-doo.
Okay, did you just say dippity-doo as in dippity-doo hair gel?
I dippity-did.
As in the dippity-doo sports gel?
Don't dippity-doubt it.
Oh, happy dippity day.
Yes, our Dippity destination today is the Dippity-Doo headquarters in Dippity... No, wait, that's not gonna work. In Mississauga, Ontario.
And we're here to meet Marketing Director Maria Mavrostamos, who's going to tell us what kinds of people like to dippity-do it.
It's an all-around gel for everyone. But the sport gel really appeals to guys, because guys like to think that they're all sporty. Did I say that? Cut, cut, cut. I'll never get a date ever. Cut.
Yep, at an impressive 50 years old.
That's the gel, not Maria.
And popping up in an estimated 85% of American bathrooms.
Still talking about the gel, not Maria.
This vintage classic has evolved from mom's must-have to an everyday essential for, well, everyone.
This is not your mom's gel anymore.
I just like that it has the word sport on the bottle. You know, it kind of fits my lifestyle.
As soon as we put the name sport on our products, which was more of an active idea, guys thought, aha, that fits my lifestyle.
Yeah, see what I'm talking about?
So Dippity-Doo begins its life as a combination of these white powders called carbomers.
Carbomers are used to stop oil and liquid from separating in the finished gel so that the Dippity-Doo will have an even consistency.
The carbomers are poured into a giant mix kettle.
That kettle is actually called a sweep mixer, which just sounds more fancy.
Then they're mixed with purified water. So pure, you could probably drink it.
The water purification system here is very stringent so that you can have a long shelf life.
Polyacrylate polymers are added next. These are able to absorb huge amounts of water, meaning that they give the gel its thickness.
Right. The quantities used are super important.
And super secret.
So they're incorporated into the blend using a special dispersing machine.
Okay, with the science part done, it's time to add the fun stuff, fragrance.
Right. This is Nimit. He's here to describe the magic of the fragrance.
We are mixing separately in a separate stainless steel container.
Stop. Give us some poetry, Nimit. Poetry.
It smell like sports.
Try one more time.
It smell like walking on a mountain.
Lovely. So all the ingredients are mixed at a speed of 12 RPM and heated to a temperature of 52 degrees Celsius.
When you're in the batching tank and they put it all together in all gels, you can see that, you know, it looks like a great gel, and it also smells like Dippity-Doo.
It does. The mix is cooled down to 35 degrees Celsius, and then it's ready for packaging.
Customized nozzles squeeze gel together with air into the bottles. The air gives the gel its iconic bubbly look, which is very important.
Yes, very important.
Those fillers are overseen by Jaspreet. She knows exactly how many bubbles make the perfect hair gel.
Maybe about okay. Not too much, no good.
This machine can fill 42 bottles each minute, meaning that in a day, Dippity-Doo can produce 60,000 bottles of hair gel.
Wow. Those bottles head down a conveyor to be capped by factory workers.
The caps are then punched on securely by this machine.
Tumari's in charge of the punching. How do you Dippity-Doo, Tumari?
My hair is too long, so I can't really put Dippity-Doo on it.
Next up, labeling, courtesy of Cirilla.
There we go.
Cirilla is here to tell us that labeling is no laughing matter.
I'm very serious about my labels.
Labels are distributed from long rolls. A back label gives a list of ingredients and instructions.
And then a front label gives the name, quantity, and strength of the gel.
After labeling, the bottles head through a date stamper.
Then the gel is hand-boxed, palletized, and sent out to Dippity-Doo devotees across the country.
To do what?
Whoa, I mean, where do I start? You've got your hipster tousled, then your hipster mohawk, hipster spikes, hipster side part, hipster no part with quiff, hipster tousled spikes.
Again?
Hipster forward comb.
That one reminds me of someone.
Hipster center part.
Yep, my great Aunt Emily.
And then the classic tousled hipster quiff with mohawk-inspired side part.
Yeah, I'm out.
Okay. You want to know what I find puzzling?
What?
Why is it so much fun to spend hours fitting interlocking pieces of colorful cardboard together?
Well, to find out, we're headed to Buffalo Games' 85,000 square foot facility in Buffalo, New York, where they can manufacture over 25 million puzzles and games each year.
And this is Paul Dedrick, the president of Buffalo Games, here to tell us why people do puzzles.
There's many reasons why people do puzzles. Some people do them to relax, some to expand their mind, some to share time with their family.
That sounds serious.
Yeah, we take our fun seriously here at Buffalo Games. We have people that can create fun, market fun, and produce fun. That last piece will always be there, okay?
The first step in creating fun is to select the image.
Someone's gonna spend 10 or 15 hours looking at this image.
It's got to be wonderful.
And that's why we're going to see how Buffalo Games' Wonders of the World 1,000-piece puzzle is made.
1,000 pieces?
Some people are fanatics, and maybe they can finish a 1,000-piece puzzle in one evening.
Whoa, how do they do that?
There's just no one right way to do a puzzle. Every way is the right way.
But there's only one right way to make a Buffalo Games puzzle. The prints are checked to make sure they're not sticking together, and then they're loaded face down into the gluing machine. And this is Michael. He's got the stickiest job in the factory.
This is technically the first part of the puzzle.
I see what you did there. Buffalo Games makes their puzzles with all natural glue. It starts out as a solid and is then melted in this handy drum. They go through 30 tons of glue in a year. So how does this machine work, Michael?
Basically, the artwork comes through a set of glue rollers, and then it actually comes down the belt. A board will come across, gets mounted on top of that. By the time it gets to the end of the machine, it gets clamped between two rollers, press it down, which becomes our finished product, our artwork mounted on our puzzle board.
The puzzle boards are made out of 100% recycled cardboard, thick enough to hold its shape so the pieces click together exactly.
Two pieces that can look so similar will not fit, and you know when you have that perfect fit.
After gluing, the uncut puzzle boards are first set aside to dry for 48 hours.
What are we going to do while we wait?
Let's go see what else is going on around here. Oh, over on this machine, the lids for the puzzle boxes are being labeled. The label has a picture of the finished puzzle so puzzlers know what they're buying. The lids are stacked and put on a conveyor belt on their way to packaging.
This is great and all, but I really, really, really want to see some serious puzzle cutting action.
Well, then it's a good thing Buffalo Games has a stack of Wonders of the World puzzles printed and glued 2 days ago.
Yay!
As they dry, the puzzle boards can curl a bit, so before being loaded into the cutting press, the edges are bent very slightly. It also makes it easier for the pusher blade to grab onto each board.
This is Don. He's going to tell us about the cutting process.
The press operates like a giant cookie cutter. It's about a 750-ton cookie cutter.
Whoa, it cuts about 50 million Wonders of the World puzzle pieces in a year, and it's terrifying.
It is. It's very scary.
Just like Don.
I get that a lot.
The board actually gets cut twice, along the horizontal axis and one on the vertical to make sure all the cuts are clean.
If you have a clean cut, the pieces are all crisply defined. They break apart properly, so when the consumer buys the puzzle, they have 1,000 pieces, not a 1,000-piece puzzle that's already half put together. So cutting is the most critical thing we do.
And to double check that each piece has been properly cut, the sliced and diced board heads over a backlit conveyor belt.
A computer takes a photo of the puzzle and checks to see how much light is shining through. If there's too much light, that means a piece is missing, and the computer stops the presses.
Stop the presses! Just kidding. I've always wanted to say that.
I think you're having too much fun.
Well, you're not the boss here, are you?
You can't create fun products without having fun.
Thanks, Paul.
The cut boards are fed into this tumbler, which uses rotating beaters to separate all the pieces.
A vacuum in the tumbler sucks away all the dust from cutting.
Then, the pieces fall into the bottom half of a packaging box.
A conveyor belt takes them to a factory worker, who puts on a lid and sends them on their way to be sealed.
Then the puzzle boxes are stacked onto skids and stored in the warehouse, ready to be shipped to... where should they be shipped, Paul?
Every house and every home in North America should have one of our puzzles because we make the best puzzles in the world. They shouldn't just have one, though. They should have many of them.
So puzzlers everywhere can enjoy puzzling out the problem of the perfect fit.
Yeah, so here's my next problem.
What would that be?
How do I get you to stop making puzzle jokes?
Now that's a real puzzler.
And we're done.